Okay. Hello, everyone. Let's get going. Can you please take your seat? Gentlemen, we're going to start. Okay. Welcome, everyone. My name is Rifat Sheikh Yusuf. I'm the new co-chair, along with Kathleen and Richard, that are remote this time. Let's get going. The note well applies here, obviously, so if you're not familiar with this, make sure to familiarize yourself with this, because this governs everything that we do at IETF. Tips, if you're in person, please use the on-site tool client. This replaces our blue sheet and allows you to get into the queue. And keep your audio and video off. For remote people, please make sure audio and video are off unless you're talking, and highly recommend that you use a headset. A code of conduct, please be nice to each other. Just a reminder, the SECDISPATCH just recommends next steps. It doesn't adopt any draft, and there are a number of possible outcomes here. They're listed here. I'm not gonna go through this. So our agenda here, we have 4 presentations. We will allocate 15 minutes for the first 3 of them, and the last one will have maybe 5 minutes if we have time. And then maybe at the end, a little bit of summary from the chairs and a few minutes from the AD at the end. Any comments, questions about this? Okay, we will start with HTTPA. Go ahead.
To thank Rifat for stepping. I would just like to inject one comment to thank Rifat for stepping up to co-chair here. I appreciate your willingness to serve.
No worries. Thanks, Richard. Yeah. Okay. Let me. HTTPA share. Okay. Sorry, I just want to mention that Tero is taking notes for us, and thank you, Tero. Okay. Who's gonna present? Is it Hans? Hans fine?
Yes, this is Hans. Can you hear me?
Okay. Let me give you control, maybe. Do you wanna drive it from your side?
You can help me click on the slides, fine. Yeah. Right,
Do you want me to
should I get started?
Yeah. You can drive it from there.
Okay, cool.
Go ahead.
Yeah, thank you. Thank you. Yeah, hello, this is Hans joining from Intel, and I'll quickly talk about the future possibility to initiate building trust for the modern internet. And next slide, please.
Okay, hold on. Take slide back. Okay, go ahead.
Yeah, so in the modern internet, it's common to see end users' identity are not well protected, and third party can easily access private content under the end identity and sub-identities of the user for its purpose. Lack of trust is a big problem, and we hope our work can draw attention, initiate some discussion, and accelerate the transformation towards the perfect vision, which is the trustworthy internet in the long-term future. So following the end-to-end principle, here we are proposing an L7 protocol to help achieve trustworthy web services. We call that the testable HTTP or HTTPA. HTTPA is simply an HTTP extension for binding remote attestation messages to HTTP headers, and it establishes secure communication for web services running inside the trusted execution environment, or I call that T, or TEE. T is a secure area of the main processor to guarantee code data inside to be protected with confidentiality and integrity. T is also considered an emerging computing resource for web services for commercialization. However, HEPA protocol is not specific to T endpoint. By extending HEP, we are proposing a fundamental method called HEP attest and a set of attest dash star header line for standardization. HCP8 workflow includes four major transactions, including the pre-flight, attest handshake, attest secure provisioning, and the most importantly, the trusted transaction. For more, for more details, you're welcome to check the internet draft we submitted. HCPA can stand alone to build its own secure communication. We call that L7 trusted end-to-end communication and L7 secure communication on the attested node. This can not only be used for unilateral HTTPA, but also mutual HTTPA for the mutual trust. Next slide, please. Yeah, and here's some background information. We have a market demand for secure web services. However, web services are mostly not attested. Also, notice that we're sailing into the new era, not just protecting data in transit or storage, but also protecting data in use in addition. A great example is T, which is an emerging technology that we propose to protect data in use and is a reasonable endpoint for HTTP message exchanges. T is an emerging resource for web applications. Mostly, it goes very well with the CPU for application developers to leverage. Hence, we think that there is a strong need for unifying remote adaptation on T for HTTP protocols, so that in the future, application developers can easily leverage T resources for their purpose. Next slide, please. Yeah, and here's a quick comparison between HTTPS and HTTPI. Although both of them have provide end-to-end security, they have different granularity levels for defining an endpoint. HTTPS needs certificate authority or CA to verify the identity of the website. And by website, it means in practice is most likely the website gateway, not the web service itself. In this scenario, if the web service is the endpoint, then there is a violation in the end-to-end principle that middlemen, including CSP or someone else, can access the communication content or secrets easily. And you will have to access in network, you will have to accept in network processing that interpose functions in the traffic. If the web service is not the endpoint, we have room to advance our technology to reduce the trust boundary further. Currently, in HTTPS, the whole website behind the gateway is the endpoint. Now, let's take a look at HTTPI. There are actually two scenarios for HTTPI: unilateral HTTPI or one-way HTTPI between the web service inside the T and the user at the end, and mutual HTTPI between two T's. In this picture, we only show the first case of unilateral HTTPI just for a simple explanation. HTTPI works with trusted authority to verify a collection of identities of the web service run inside the T directly, including genuine hardware, software vendors, etc. HBA can also provide a simple and unified way for users to authenticate the web services to build trust by remote attestation. Remote attestation is the key method we propose to verify all sorts of identity set for including software, hardware, for finer granularity authentication. And that's what I mentioned previously, the new HTTP method we are proposing, HTTP attest. So that user can expect the thing will happen as it is in the remaining HTTP transactions inside the T. In this scenario of HTTPI, web service is the endpoint. Middleman between the web service and users cannot access the encrypted content even in the situation without TLS protection. And they cannot forge the identity either, because HTTPA allows an endpoint to select a part of the message for encryption. We call that selective privacy. And the whole communication between the endpoint will be protected with authentication and integrity guarantee through the T. In some strong T, users can only rely on the web service itself for their sensitive data, even without the need to worry about the potential interposition from the middle boxes. Even though middle boxes are mostly benign and useful, such as an L7 application gateway. Yeah.
Sorry, there are a number of people in the queue here. Do you want to take this comments right now? Okay.
Sure.
Okay, Roman.
Yeah.
Hi, Roman Dinudu, Carnegie Mellon University, no hat. Just to kind of clarify, I'm sorry I came up and down because I was trying to understand the setup here. So it really isn't about how many middle boxes are here, whether it's an application gateway or the fact that the TEE is on a box. The setup is you want to tunnel from the TEE irrespective of how many middle boxes are there to the user. That's the motivation for the extra headers.
Yes.
Okay, thanks.
Yeah.
Hannes.
Hi, Hannes Trefenik. In general, if you put a TLS gateway somewhere in front of your web services, the expectation is that you would offload the TLS service. That's why you put that in front of it. So I think from that deployment point of view, nothing changes. If you don't want that offload, then let your TLS go all the way to the end. Having said that, you could probably, if you want to truly have it end-to-end, you could put something into the application layer, which would be simpler and wouldn't require modifications to the HTTP protocol itself. And you could also sort of layer different sort of a TLS protocol on top of the application as well, if you want so. But I'm curious on why you don't want to just go the simplest route, which is if an application needs it, put that information into the application. And by the way, certificate authority should be certification authority.
Wow, thank you.
Go ahead, Hans. Do you want to answer?
Sorry.
Hold on, Jonathan. Just one second. Hannes, do you have an answer to what? Do you want to answer, Hannes?
No, you can go ahead. Yeah, go ahead.
Okay, Jonathan.
Jonathan Hoylands, Cloudflare. So your HTTPA communication is giving you confidentiality, integrity, all the things you want. Why have a TLS channel at all, right? You can just do this over like raw internet packets, and adding the TLS channel is just sort of adding noise. It doesn't really help anything. What's the security guarantee you want from the TLS channel? Why aren't you just doing this over raw internet?
Yes. So for the TLS channels, it's not necessary for HTTPI, and we don't necessarily need that. So this is the kind of things need more discussion. I think that essentially the users, the interest, that what they are interested in to verifying the identity is that the website or the web service itself. That's kind of the question we're trying to answer. And if it's the web service itself, nothing related to the website, then probably HTTPA is good enough. However, you know, most of the scenarios we have a ingrained trust in the TLS, and we need some experiment part to see if we only have the pure HTTPI and what that in that perfect scenario, what the user experience will look like.
So I was just flicking through your draft. I didn't read it in detail, and I just noticed that there's no attempt to bind the HTTPA or the TEE to the TLS channel. So I really think it isn't doing anything at all. I think it's just noise.
Yeah, you could put it that way. It doesn't rely on TLS.
So just a quick time check here. We have about 5 minutes left in the slot. So Hans, we would like to have some discussion and get to a dispatch outcome here. So I don't know if you want to go over into feedback now or present a few more slides. But if you could kind of get to the end of the presentation and have some time for feedback, that'd be great.
Yeah,
I was going to say that,
thank you.
like, maybe like if we want to have any discussion, we need to like have like no more slides or one more at the most. So I'm happy to wait for it, but like, what would chairs like to do?
Sorry, what was that?
Yeah.
I said if we're going to discuss this, we have to like have this presentation end very, very soon. So like, what do the chairs want to do?
Yeah.
How many slides do you have? How many further slides do you have?
This is the last slide.
One?
So it's
This is the last slide.
there's another last slide trying to discuss where do we go, but this is probably the last slide for the content.
Oh, good. Okay.
The discussion, yeah.
So
Okay.
yeah, I think this is the wrong layer. My question is somewhat like Jonathan's, but I think perhaps more straightforward. The right place is at the TLS layer, not at the HTTP layer. I understand you like want to have like a gateway, but like this is going to create all kinds of confusion about the situation in terms of like what can the gateway do and what the gateway cannot do. If you allow selective encryption or selective signature, like there's been like all like history of enormous amounts of shenanigans with selective encryption, selective signature. So like the right way to solve this problem is to like have this like terminate on the TLS server. If this problem need be solved at all, which I am like somewhat skeptical of. And I think so. Saying that maybe I'll even back up and ask the question: how do you envision this being deployed? So is this for the web, for instance?
We envisioning this for the web instance, yes.
So how would a browser consume this information and present it to the user? Let us stipulate this all worked.
What's that?
Let us stipulate this was perfect. How would the browser consume this information and present it to the user?
Yeah, so this requires some we need to build some shared library and then have some browser plugin that we have some browser plugin to parse that information for this communication.
No, I'm not asking how the protocol works. I'm asking what the browser shows the user. But that even brings me another question: is any browser interested in this?
So far, I'm not quite sure yet. This is still kind of a concept so far. Okay,
so I think that's for me that would be the predicate question for taking this up for IETF. So I think the answer from my perspective, and perhaps other browser vendors have similar ways, is come back when some browser is interested.
Okay, Mark.
See, this is the problem when you can sit down and be in the queue. So I have significant concerns about how this uses HTTP. I think it's maybe an extension of Ecker's comments about the layering. I'm not at all sure that this is an appropriate candidate for a new HTTP method. And I'd encourage you to read both the HTTP semantics document on HTTP methods and what the requirements for them are, as well as BCP 56. I think I've communicated this before, this is not a good name. HTTPS was probably a mistake. I think this is an extension to, how did that happen exactly? If this is going to come in at the HTTP later, which I think is a big if, it's an extension to HTTP. It is not a new name to HTTP. But I think what really needs to happen is the community needs to have a discussion about use cases, requirements, what is the right layer to have this come in at, rather than just having a solution saying, look, here's a new HTTP method. So let's have that discussion if there's interest in that discussion.
Okay, we have 1 minute here. So Ben, please go ahead quickly.
Hi. I just wanted to encourage you to look at the existing multi-layer work in HTTP, particularly HTTP Connect UDP or MAST, and Web Transport. That seem like they can probably express this in a more natural way, where there's a TLS session to the gateway, if there's gateway level logic, and then an end-to-end TLS session into the trusted environment inside that.
Thanks.
Ted?
Dispatch outcome, I recommend no action at this time. I strongly agree with all of what Mark Nottingham said about its use of HTTP. I think the method is completely in need of a rethink, and I think some discussion as well about how it's using the headers. If it stays at the HTTP layer, it needs to start over. And I think Mark is correct that it doesn't belong there. And so I think no action.
Thanks, Ted. Danielle?
I agree with the no action from other people. I also think that there are some pretty serious privacy concerns if this would actually apply, if the server could request attestation from the client. I heard bidirectional early on, and this strikes me as some kind of mega cookie of like, I'm going to prove that I am this particular device. So I think no action. There's a lot of unanswered questions here, and I don't think it's fully baked enough even to start.
All right, so just to wrap up the dispatch outcome here, sounds like there's pretty good consensus. There's no action for now, and there's some good feedback that there's needs to be a little bit more thought of how this fits in with the TLS, HTTP, web transport sort of architecture. So thanks for the presentation, Hans. And next up is...
Thank you.
Secure routing.
Yep.
And mailing. Okay. Is mailing around? Either remote or here? It doesn't look like it. No? One? Oh.
No, I don't see her on the in Meet Echo.
Okay, let's move on. Next one is signed public key. Let's see. Okay, Graham. You want me to hand you control? Yeah, okay, so let me.
Hi, my name's Graham Leggett. I'm brand new, so please be nice to me and don't jump on me.
Yeah,
I can, as long as no one bites me, that's fine. I wear a number of hats. I come from Apache Software Foundation, did a lot of work on HTTPD way back when. Further to the present, there's a project called the Redwax project, which is aiming to put a whole lot of web-based technologies, anything that crosses security in the web, like SCEP and this, Sign, Public Key, and Challenge. We're trying to find things that are broken and fix them. And one thing that's broken is this. So if we can jump to the next slide quickly.
It's not working for you?
No, am I?
Okay, let me take back. I'll drive the slides.
Yeah, let me.
Okay. Go ahead.
Just reading from my notes. Sorry about that.
Yeah, no worries.
Cool. So what is it? It's an ASN1 structure. It contains a public key and a challenge, as you would imagine from the title, and they're signed. And that's basically it. If you jump to the next slide, what I'll do is go into some history. Some people might be old enough to remember the 1990s. There was a company called Netscape, and they invented a thing called a web browser. Some people might be familiar with that. And inside that web browser was a thing called the keygen tag. What the keygen tag did is if you embedded that on a web page, what the web page would do is generate a key pair for you, and then submit proof of possession of that key, that private key. It would send it over to the server. And if you were a certificate authority, you could then use that mechanism to hand out certificates. And that worked for about 20-ish years. The keygen mechanism eventually became part of the HTML5 specification. You can jump to the next slide quickly. So at the same time, also in the 1990s, there's another company called Microsoft that people might have heard of. They invented a different mechanism. There was a big fight between the Netscape people and the Internet Explorer people. Same problem being solved, problem being that the private key was generated in the browser and never left the user's possession. Their decision on how to solve it was to use a certificate sign request, and that was the thing that went over the internet. This still exists. You can have it. It's called It exists inside Internet Explorer compatibility mode if you use Microsoft Edge. Anyway, we jump forward. If we jump forward one slide, and about 15 years, Firefox and Google in the mid-2010s said, yeah, nah, we're going to take this out. And specifically, they took out keygen from the browsers, and they took keygen out of the HTML5 specification. Justification, quite valid, really. First one, the message format that I described a very short while ago was never written down. It existed, it was widely deployed, but no one ever standardized it. And it's now code that is lying around OpenSSL, it lies around inside NSS, it lies around all sorts of places. It is not a standard. And for that reason, I'm standing here now. I hope to make it a standard, just so that at the very least we can put a bit of history under this piece of the internet. So if you jump to the next slide, we get to the point of why bother doing this work in the first place. The first reason is that code exists. It exists in OpenSSL, it exists in NSS, it exists various places on the internet. And this code allows you to create a message, and that message allows you to prove that you possess a private key. We don't like throwing away good code. It's been there for 20 to 30 years. It's widely deployed in all sorts of operating systems, all sorts of libraries. Throwing it away is a waste. In addition, we still want to prove that we possess private keys, and we don't necessarily want certificates to be involved because things like DANE and DKIM and so on exist, and they don't necessarily cover certificates. So there is still a need for this problem to be solved. So if we jump to the next slide, the goals of this, if I zoom in on my phone because I can't see properly, the goals of this is to formally define the SPKSC format properly to the standards of the IETF, and then go to each of the implementations out there. OpenSSL is one that's already been done, but there are others, and update those implementations to make sure that they are clearly indicated as following a standard, and fix any shortcomings in them. The big shortcoming that did exist in OpenSSL was that despite signed public key and challenge not depending on any particular kind of hash, the guys who came up with keygen said MD5 is good enough for everybody, and they hard-coded that into keygen. Obviously, that is evil. And in this particular spec, we've updated it to indicate 2020's practice, and don't hard-code your hashes. And the end goal ultimately is we want people to be able to use this message to prove they're in possession of a private key. If we jump to the next slide, we get our non-goals. So one of the things in the specification is that, yes, there was a lot of history, Netscape, Microsoft, etc. At the end of the day, this particular specification only focuses on proving you have a private key. It doesn't go into keygen. It doesn't go into cert-enroll, which was the name of the Microsoft implementation. That is all history of where it came from and how we got here. However, that ultimately isn't important in the spec. We do not want to change the format. It works entirely fine as it is. So if you jump to the next slide, where next is the question that we're asking at this point.
Okay, Michael.
Mike St. John's. One of the things we encountered fairly recently was the issue about dealing with proving possession of non-signing keys. Is that something you just don't want to do here?
That is another problem. So we would like to solve other problems, but our primary thing is to make what exists today a standard, because I'm quite sure that whoever invented it in 1990, whenever, intended it to be a standard, and they didn't get that far. So we're sort of coming decades later and sort of finishing the job. There are certain things that we're probably not going to solve, or maybe we can solve in a further iteration of this. But certainly the first goal out of the door is to standardize what's there so that people can then use the code confidently, knowing that it's not going to get ripped out of OpenSSL, so on.
Okay, Eric?
So as I understand it, you don't want to change the format at all, right?
That is correct.
So the correct venue for that is an informational RFC published via AD sponsorship. I will say I have some doubts about the merits of this idea, but like, fortunately, we don't have to debate those. I agree, documenting is some value, and the correct venue for that is via AD sponsorship. If you want us to, if you want us to screw with it, then we can talk about standardizing it. But if we're just gonna like rubber stamp it, write it down somewhere, that's the way to handle it.
Okay.
Jonathan?
I agree with Eric. Obviously, the correct thing is just informational RFC. But if you are changing something, i.e. changing the use of MD5, then you are not documenting current practice?
So MD5 is historical practice, and it's practice of someone who made an implementation where this was part of an implementation.
Is there an implementation that exists today that is not using MD5?
Yes, so OpenSSL is fixed. It cannot use MD5. Anybody who implements keygen today would need to have a field that says, what kind of hash would you like to give me this in, as opposed to just, because previously it was an oversight. Whoever did this 20 years ago, they just hard-coded MD5 because it's good enough for everybody. So all it needed was a hash equals name of hash. So this isn't a huge, it isn't a huge blocker, because there's nothing in SPKAC that says you have to use a particular hash. There's a field that just says, what hash did you use? So from that perspective, I think it is quite, we have to be quite, I mean, we as the royal we of writing the spec have to be quite careful about not conflating misuse in the past where someone hard-coded a hash to what this spec tries to achieve. And that's just, here is a message format. The message format doesn't dictate a hash to you.
You can write an informational RFC, document it. If you want to change it, there are about 1,000,000,001 different options that already exist today that do basically this.
Yeah, so we don't want to change it, is the short thing.
Robert?
In the point of not wanting to change it, there are a couple things probably which make an awful lot of sense that should be there, which are not. For instance, a timestamp. So I would recommend that your document say, not just we're following the format, not changing it, but also how you deal with or accept that you don't have those other fields, that you're accepting that this format doesn't have them, and why it is an acceptable practice not to have them.
Yes, I think that this sort of, so we have code that exists today. We've specified the specification of how the code works today. This is a very compelling reason to change it. What would be great is to change it in such a way that it is backwards compatible. But certainly, yes. And what I would like to do is get your guidance as to where we go next in the long term.
Yeah. It's like your document. I would like if you take a couple of these key points and say, yes, it would be nice if we had them. We're not having it, and here's why it's reasonably okay to move forward without them.
Yes. Okay. Because essentially the challenge part, I think the idea behind the challenge was that was your we're not going to replay this.
Somebody else may replay it.
Yeah. So I think a possible challenge could be a combination of something and a timestamp.
Right.
Is a potential challenge. So whether we add an explicit timestamp or whether we just say, if you would like a timestamp, put it in the challenge, because the challenge is just a string.
Yeah, so I get it as an example. There's probably more that I don't know about, but it'd be good if you had text discussing that.
Yes, definitely feedback is something we'd like at this point.
Deb?
So I just want to ask a couple questions. This includes keygen or no?
No, it does not include.
Not include keygen. Okay, so then I'm not interested.
Daniel?
I am interested in keygen, but in terms of this specification, it's separate.
I just wanted to observe.
I know I'm not getting keygen back. That's the thing that Right, but keygen is the thing I need, but I know I'm not getting it, so it's okay.
Yes,
So Daniel, go ahead. Sorry.
So this is, for dispatch questions, this is clearly informational because no one's going to get actual change control if the goal is just to write it down. And I really think, I mean, I'm going to agree with Bob that the lack of context for this challenge protocol is pretty problematic from what we currently know about how to design protocols. But I'm going to disagree with Bob that the thing to do is to write down, here's how to do it right within this. I think the thing to write down is security considerations that say, here, it's missing all this context. We know better than how to do this today. You shouldn't use this. You should use some other protocol. If this is going to be written down, I really think the security considerations need to call out the fact that this is missing stuff we've learned the hard way over the last 15 years.
Okay, Stephen.
Hi, sorry, Stephen Farrell. I'm still confused. So you say this keygen is not part of this? Is it for something else, or is it only for? I'm confused. Sorry.
So keygen is a superset of SPK-SC. So SPK-SC, keygen is the
I understand that.
overarching process of browsers and requests that keys be generated, etc.
Yeah.
SPK-SC is purely the message that gets sent from the browser to the server saying, I possess the private key.
But if you don't want it to use it for keygen, what do you want it to use it for? I'm just confused, and the dispatch answer is different depending on the answer.
So it depends. There's certain things like if you have an app of some kind, probably not a browser, because generally the browsers don't let you do this, but if you had an app of some kind that said to your DNS provider, your DANE provider, I would like to roll over my key, and I would like to prove that I possess the old key, I'm going to tell you a new key. Here's proof of possession of my old key. Please update my new key. This could potentially be used in a system like that without inventing from scratch a mechanism to prove that you possess a key. So this code, this ability is built into libraries, all of the rest of it.
Okay.
If you had that use case, and I certainly will do in the future, is the ability to go, I have this key and I can prove it, and I don't need to write that from scratch. I can just use this library function, which depends upon this.
I get it now. So I think on that basis, I would say no action, because we have lots of choices to do this where you have just as many implementations as far as I know, or even more. So I would think no action on that basis.
Okay, Roman, do you want to
right, thank you.
wrap it up? Go ahead. Richard, do you have a comment? No?
I was just going to summarize the discussion so far and then hand it off to Roman.
Yeah.
Stephen's closing comment notwithstanding, it seems like there's general direction of the room is toward openness to AD sponsorship at the informational level. But I'll let Roman comment on his willingness to sponsor it.
Hi, Roman Dinilu, one of the SECDIs. Yeah, in the spirit of making sure open source implementations of crypto stuff are well documented in interop, and this is a small document, and as we talked on the list, that we are documenting in an ASN1 format and providing good advice on top of that and nothing more, I'll AD sponsor it as informational.
Thank you.
Okay. One thing I'll also capture in the summary for the minutes, though, is that it's going to be important to get the security considerations right here. I think there's a bunch of notes in the chat, and it was raised by Bob and I forget who else at the mic. That this is clearly something that has sharp edges, and if you're going to integrate it in a new app, that you should be very careful with it. So I think that's. I hope the authors can take that feedback and adjust accordingly.
Okay.
Good.
Thank you very much. Yeah. Tom.
Hello, everyone. My name is Tom Franke. I'm affiliated with arpa2.net. I'm also new here, so thanks for the opportunity to have some time here to pitch our draft. We have been working, next slide please, on a draft about a TLS extension called TLS KDH. I don't have the time to go into all the technical details, but I really would like to have some feedback on the idea in general. Is it feasible or not? And where it should land, either in a work group or in an independent stream or not at all. So feel free to roast me if it's bogus. So I'm going to give you a short introduction into TLS KDH, what it is. describe some abstract use cases, and then have a short discussion. Next slide, please. So we've been drafting a specification on a TLS extension that enables Kerberos-based authentication for TLS. We call it Kerberized Diffie-Hellman. And we basically combine the worlds of Kerberos and TLS. Without going into all the details, the idea is that you get your ticket from the KDC and use that in a TLS handshake to get a nice channel binding and use the ticket to mutually authenticate both parties. Next slide, please.
Yeah.
So we have defined two modes of operation. KDH only, that means that you use only the client ticket to mutually authenticate the server and the client. And KDA enhanced, that means that you have regular server to client authentication based on a certificate, for example, X509, and you enhance that with a client ticket to have Kerberos authentication as well. Next slide, please. So what could be potential use cases? Without going into much of the concrete cases, KDH, so Kerberos-based authentication, could be an alternative to PKI, as well as pre-shared keys. So it depends what you need, what your security requirements are, but there are certain use cases where you want a centrally managed system, where you have a KDC to manage your users. A nice side effect of Kerberos-based authentication and the channel binding that we have achieved is that you also harden your TLS channel for quantum computing attacks, because you can seed it with symmetric entropy. So that could also be an interesting use case. The other way around, we can protect Kerberos sessions with TLS and then achieve perfect forward secrecy, which was also not possible currently. And we could use TLS KDH as a Spinego alternative or replacement, whatever you want, because we achieve basically this authentication on the transport level instead of on the application level. Next slide, please. So that was it in a nutshell. The question is this a viable idea? Is it feasible? Is it applicable? We have our own ideas about this, but your experienced input is very welcome. And if we should proceed, where should we go? And if we should not proceed, then too bad.
Hey, Eric Scorla. I don't know yet if it's viable. It should go to TLS. So I mean, I skimmed this draft and like I was sufficiently like unsure about some of the details that like that came maybe come to the conclusion that should go to TLS if it should go anywhere. Just like like so the bit where you're like doing your own signature with like the Mac on the keys and stuff. It's like maybe it's right, maybe it's wrong, but like it's got to be like we have to look at it more carefully. So I guess my question would be like. I think that now when this comes to TLS, my predicate question will be who's interested. So I think like, when you come to TLS, you should be prepared to say like, these are the following implementers and they want to use it. But I mean, conceptually, there's no problem with the Kerberos TLS binding. And as you know, we've done them before. The details obviously matter. And so the question of whether IETF should bother to like invest in it kind of comes down to like, comes down to interest. I will say that it's possible you can get it down. I think it's a problem a little bit, and it's possible you can get it down to be a very small extension, in which case maybe you could do it just on your own without TLS review. But if it's as complicated as this document ends up having to be, then it will have to be in TLS.
All right.
Alex.
Hi, Alex Chernowski. I was curious if you were using this for authentication or authorization or both, because I think that somewhat changes what I think about this.
Well, primarily authentication, but of course you can also do authorization with Kerberos. But that's up to the end applications. So basically, you can use the authenticated channel to do Kerberos things.
Right. I don't think you should try to use this for authorization because that works very poorly with the web. Like the whole browser model, which is why client search are disfavored, is because you end up with really bad user experience. So like, I'm kind of curious if you want this for machine-to-machine communication, or if you're looking at this for like end user to server communication. Because I think that if you're looking at it for like end user to machine communication, you're basically going to run into the same problems that we had with JSAPI and SPNego, and I would say that this is not worthwhile. But if you're looking at it for machine to machine, my immediate question is, why aren't you using the existing JSAPI channel binding mechanisms with TLS and like let TLS do TLS stuff?
That's a good question. I don't have a direct answer to that. We can have a discussion about that offline.
Thank you.
Yoav.
Yeah, so lots of years ago, IPsec had a similar proposal, and we have the KINK RFC 4430, Kerberized Initiation of Keys, as kind of an alternative to the Internet Key Exchange. And this saw really close to zero implementation and close to zero use, because nobody really wanted it. So for this proposal, is there any real, I don't know, customers, people who really want to use TLS with the Kerberos keys?
Yeah, that's of course a very valid question. We within our own project, we have some use cases for this. We also heard some interest from the Radius group. They were also looking for alternatives, and Kerberos was an interesting idea, they said. And we also reached out to Microsoft because they're doing a lot with Active Directory, Kerberos, single sign-on applications. So we're still discussing that, but we do think there is a group of users that might be interested. Yeah.
Okay, Jonathan.
So the obvious dispatch method would be send to TLS. But having just looked at the spec, this does changes to the TLS key schedule and it breaks some of the assumptions used in all of the security proofs. So if you do want to do this, can you come with like a formal analysis and a proof that you haven't broken everything? Because I don't want to have to redo that. It took ages.
Yeah, that's also a very valid point. And that was one of the details I didn't want to go into right now, because indeed we have an alternative for TLS 1.2 and for TLS 1.3, because the key schedule is completely different. We don't think we break any security, but of course a formal verification would be nice.
You break the security proof, right? So there's a proof that TLS is secure. You definitely break the proof.
Mm-hmm.
So you'd be using something you don't know is secure, which is not the same as is not secure.
Yeah, no, that's true, and that should be checked, of course. And for TLS 1.3, we generalized the mechanism that we used, such that it can also be used for other mechanisms than TLS KDH to provide entropy. So that would require proof for every new mechanism. But that's definitely something we will look into, and we also have capacity within our project to do so. Yeah.
Yeah. So the other thing I would say is I have a now expired draft on TLS extended key schedule, which lets you inject stuff into the key schedule with a proof that you're not breaking anything. Mm-hmm. So maybe like consider using that.
Yeah. Thank you.
Okay, Richard, do you want to summarize this?
Yeah, so that brings us to the end of the queue. Thanks to everyone for your comments. Sounds like our outcome here is immediate action. If there is some work to do here, it'll be in TLS. And questions heard we'd need to address in the TLS working group, or is there an audience for this? What's the market for it, as it were, and how do we verify that it's secure? So sounds like that's some good feedback. I think that kind of indicates the next steps is to start some discussion on the TLS list. So thanks for the presentation.
Thanks, Tom. Any other comments from you, Tom? You good?
No, thank you very much for all the feedback, and we will follow up.
Yeah, thank you. Richard, do you want to provide a summary, and then I'll let Roman kind of wrap it up here for us?
Sounds good. So by my notes, our outcomes today on HTTPA, there is no action for now. We need some more thinking about how to integrate with the stack and who needs to be engaged on that. So no action for now on HTTPA. Secure routing we skipped because we didn't have a presenter. SPKCA, I think there was an A at the end. It's SPKAC. There we go. That's proof of possession thing. We agreed to send that over to the ADs for AD sponsorship as informational, with a bunch of notes about security considerations and use of this in new stuff. And on TLS KDH, the feedback was that this is work should happen in TLS, if anywhere. So discussion should happen on the TLS list. So with that, over Roman.
Okay, thank you, Richard. And Ron.
Hi, everyone. Roman Janilio, and so I'm kind of speaking on behalf of kind of Paul and me. Probably, I think 2 weeks ago, you saw an announcement on the SecDispatch list about how we are rethinking the approach to leadership. SecDispatch is one of those standing working groups. It will endure hopefully forever. It's been quite a bit of a success in helping us manage the portfolio of things coming in to the SEC area. We hope it's made it a little bit easier to bring new ideas, kind of for those proponents that may not know what the entry point is. What we didn't want, of course, is for those in the leadership team to have to be there kind of permanently. And so what we've defined is a rotation kind of schedule that we published. And so notionally going forward, the thinking was that we would be looking at terms pushing around kind of four years time, and those chairs would rotate as that occurred. Of course, if something changed, they could step out earlier. So we made some kind of announcements kind of relative to that. So welcome to Rifat. Kind of thank you so much for your willingness to serve. I wanted to again thank publicly Mohit, who had stepped out a little bit earlier due to his really great new job opportunities. And with the rotation that we've set up, exiting out of this working group will be Richard. Please flip your video on. And the long-term plan, starting kind of this time, midsummer next year at IETF115, Kathleen will be approaching year 4. And so whoever the ADs at the time will make the next selection. And we hope that this really creates that pipeline of rotation into the organization. What I want to say here kind of in close is, Richard, please get on the video. I wanted to say thank you to Richard. I think the SecDispatch process has been really an amazing addition to SEC process. I know as an AD, it's been invaluable to get your community kind of feedback. And I think from what I've heard from folks trying to bring new work here, this has very much helped them. That does not happen in a vacuum. That really starts with kind of strong facilitation by the chairs. And Richard, you've been here since the beginning and helping us first launch that process and really show us how it's done since we started almost 4.5 years ago. So as you step down, I wanted to kind of say thank you for your leadership and helping us manage the area. So you're not in the room, but we're going to clap for you anyway.
I appreciate it, Roman. Back when I was ART AD, I was a beneficiary of the dispatch process in the ART area. So I definitely was supportive of having a similar thing in the security area and was happy to help set that up. So happy to help and happy to have new leadership here. So thanks again to Rifat for stepping up. And to those of you in the crowd, I think we're going to have another role here in a year. So start thinking about whether this might be of interest to you.
Awesome. Thanks, Richard. Any other business? Okay.
And this is Kathleen. I also want to thank Richard as a co-chair for the last few years. So thank you very much.
Awesome. Okay. Thank you, everyone. We're done.
So yesterday we spoke with Dave Taylor, and he pointed to the right persons in Microsoft that actually know something about
Yeah, you didn't respond yet. So